Okay, right here is the definition for parallel lines. I want you to put a box around that. It tells us if we're talking about parallel lines, what can we expect? They lie in the same plane. What's a plane in the mathematical sense? What do they mean by plane in the mathematical sense, right?
Coordinate plane.
Well, it could be a coordinate plane, which would be a graph, or it could be, it's not really a line. A plane is actually two-dimensional. So an example of a plane is like the floor of this room. The ceiling of this room would be considered a plane. The desktop you're sitting in front of, the desktop itself, just the top, not the whole desk, is two-dimensional. It is considered a plane. So when you have two lines that lie in the same plane and they have no points in common, we say that they will never intersect and they are parallel. Okay? Well, here's the other thing that we can count on. So let's use a different shape for that one. If lines have the same slope, but different y-intercepts, in other words, they do what? Start.
The starting points are different.
Yeah, they start in different places. What would happen if they started in the same place?
They'd be the same thing.
It'd be the same line, they'd be like right on top of each other, wouldn't they? They started at the same place and they had the same slope, their rise and run was exactly the same, they'd be on top of each other. Then would they have points in common?
No.
If they're on top of each other?
Yeah.
Yes.
Yeah. Could they be parallel then?
No.
No, parallel lines can't touch. So they have to start at different places, so they have to have different y-intercepts, and they have to have the same slope. So we have to, that's how we can determine if lines are parallel or not, right?
So if two of the same exact lines are on top of each other, then wouldn't it be considered just the same exact line?
It would be, yep. In fact, and there's a term for that, they're called coincident lines. So they would be, our question was, can those coincident lines, or the same line, can it be parallel to itself? No, it can't be parallel to itself. Okay, so what you're going to be doing in your homework today is you're going to be identifying from equations whether lines are parallel or not. And then you got to graph them to verify your findings. So here's an example that's done for you. We have the y equals negative 2x plus 4. Notice what they did for work. Identified the Dakota.
Identify the slope.
Okay, they identified the slope and the y-intercept. Why is that important that we identify both of them? Well, partly so that we can graph them. That's going to help us too, Josh.
So we can graph each other. The y-intercept shows us where to start.
Y-intercept shows us where to start. That's for graphing again, but remember, what did we just say above? Trey?
Right, so we have to check all of the other ones to see if one of them has the same slope.
Okay, we want to check to see if they have the same slope because what if they do? What are we going to say?
Then they could be.
Then they could be parallel. Yeah, that was a good word to use, Trey. They could be parallel if they have the same slope. But
They have to have a different starting point.
they have to have a different starting point. So we have to identify the y-intercept because that's the starting point. If they have the same slope and the same y-intercept, we already decided they can't be parallel, right? So that's why we're going to identify both the slopes and their y-intercepts. And after we do, we notice that on this example that's done for us, this one and this one have the same slope and they have different starting points. They have different y-intercepts. So we say that those two are parallel because of that, and then they are graphed to verify that they do look parallel. They look like a pair of railroad tracks. Okay? So let's go down and practice ours. We have two of them we're going to practice. Identify which two lines are parallel and then graph the parallel lines. So here's what we're going to do. We're going to take each of these and we're going to write them down. And underneath them, we're going to identify the M and the B. And the good news is they're in slope-intercept form for us, so we can go right to picking out the M and the B right from our equation. So what's the slope of our first line here? 4. And its y-intercept is 2. Okay. Now we're going to write down the next one, which is y equals 2x plus 1, and identify its slope and y-intercept. Dakota?
Okay, since I'm a man of simplicity, can I just identify the ones with the same slope and then do exactly what you did? Is it like an unbelievable?
You're just gonna play along with this because we have when we do the next type of lines, it's going to be helpful that we just stay in that habit of identifying slope because now there's gonna be a different rule. So even though you're a man of simplicity, feel free to join us, those of us who like to make it harder. Okay, what is the slope of this one? 2, and 1 is the y-intercept. Okay, and last but not least, we take our third one, which is y equals 2x minus 3. This one's got subtraction, so let's make it add the opposite. What's its slope and its y-intercept? 2 is its slope, negative 3 is its y-intercept. So do we have any parallel lines here? First and second, first and third, second and third. All three of them are parallel to each other, Cameron?
The second and third.
The second and the third ones should turn out to be parallel. So, do you have, I think you should have, do you have enough white space down here still to write which ones are parallel? Because that's what we're going to write it out, okay? So let's write out that y equals, we said the second and the third one, so y equals 2x plus 1, and y equals 2x minus 3 are parallel. Okay? Now, you only have 3 problems of homework to do. So for those of you who are just still looking for shortcuts, you know, give it up. Okay? Or we can make the assignments longer for you. Maybe that could be a choice for you. If you want to be, you know, I can triple your assignment versus the other people. Okay, what are we going to do then? It says then graph the parallel line. So go ahead and graph both of those. You know how. Find your, what you're starting, and okay, let me caution you on something. Now when we are starting to graph more than one line on a graph, make the points for one line, draw its line through the points, and then go about doing the second one. Because otherwise what ends up happening sometimes is we can't remember which points went with which line. It's hard to tell. And I'm just sure over here.
Gotta have a lot of zigzags. Come on, just pass it. 3 seconds later, I was just
Okay, who didn't get it? So after you graph the first one, I have mine up there, you can verify, see if you agree with where it's at. And so in other words, maybe what some of you might still need to be doing is saying, okay, what are the different ways I can do it? I have a positive 4 over a positive 1, or I can do a negative, oh, that isn't the one we're doing, why am I doing that one? How about we have m equals 2, that means we can do a positive 2 over 1 or a negative 2 over negative 1. They both have the same slope, you only have to do that one time. Okay, I think some of you have forgotten also our little rule about, after we're done graphing, we should check the behavior of the line and see if it matches our slope. So our slope is positive or negative, 0, what is it?
Negative.
Slope is negative?
Or,
Positive. What's the behavior of a line that has positive slope?
Right, just from
Rises from left to right. Ours is rising from left to right, so feeling pretty good about that. They don't look like they're ever going to touch each other, do they? No. So feeling pretty good about that. So as I was correcting your quizzes last night, some of you you're not remembering to take the time to stop and say to yourself, there was a positive slope, but yet my line is falling from left to right. That should be a problem. Okay, so anybody have questions about number 1 at all? So this is what we need to show. So any questions about that? Okay, let's do one more and then I can get that worksheet up to you. Okay, so let's start with writing down our first equation. And it's already addition, so we can go right to identifying its m and its b. What's the slope of the first equation's line?
negative 2 or 3.
Negative 2/3. And its y-intercept is
1.
1. Okay, let's do our next one. Y equals negative 3/2 x plus 1. We need to identify the slope and the y-intercept. It was already addition, so we don't have to change it. What's our slope for this one?
Negative 3.
Negative 3/2. And its y-intercept?
1.
1. And then our final one. We have y equals negative 2/3 x minus 2, which we'll change to add the opposite. And say that its slope is negative 2/3. And its y-intercept is negative 2. I'm sorry, try that again for me to go ahead.
I read all my homework, all 3 problems, we're gonna have 4 different slopes and slopes.
4 different equations?
Yeah.
That's a possibility, I suppose.
Okay.
Okay, are there any parallel lines here?
Yes.
So, first and the last star. Okay, so we're going to say then that y equals negative 2/3 x plus 1 and y equals negative 2/3 x minus 2 are parallel. And why can't we say that negative 3, 1 has a slope of negative 3/2? Isn't that the same thing? Negative 2/3, is that not the same thing as negative 3/2? No. It's the reciprocal of it. And this doesn't say they can be reciprocal, does it? Okay, let's take that slope, m equals negative 2/3, now get ready to graph. If the slope is negative 2/3, what are the 2 rises over runs we can use? What's one of them? Isaac?
Negative 2 over 3.
Negative 2 over positive 3. Or what's our other choice that we have? Okay, Mia wants to offer up 2 over negative 3. Okay, so let's go back to those ones that we say are the parallel ones. We need this one. We need a starting point of 1. And we need to go down to 3 in the positive direction. Or we can go up 2 and 3 in the negative direction. Draw a line through it. And right away, before we even move on, let's decide, we like the behavior of that line. Yes, we have a negative slope, it's falling from left to right, feeling pretty good about that. Okay, now we go to our other one where the starting point is -2. Use the same rises and runs. So we can go down 2, 3 to the right, or we can go up 2, 3 to the left. And it appears that they are going to be non-intersecting lines. So looks like we picked the right and correct 2. Okay, anything you don't understand what you still need to be able to do here? Or need to show, or Isaac?
So how can you tell if it's, which one is which? Like, does it have to have the same slope?
Yes, they have to have the same slope, and what else?
Can have the same starting point.
And they can't have the same starting point, they have to have different y-intercepts. So, the reason that we decided it was these two equations is because right here, we look at their slopes and their y-intercepts, and we say they have the same slope, they have different y-intercepts. That's why we picked those two, okay? Anybody else? Okay, there's as much room on here as there was on the notes, so you can decide if you want to just do it all right on here, or if you feel like you work better on lined paper, then you can get out loose leaf paper and get it.
What?
I was short one and then another one. Who's the one that did get one? You again? Okay.